We're at a place where we have a clone of our desktop application residing on a container registry. That's not super useful. It doesn't run. So if we ran that using like Cloud Run or Kubernetes, it wouldn't actually do anything. It would just be a clone of this desktop environment. A more useful thing would be to use Cloud Build to detect changes to your Git repository and then build all the code and upload it. Now you can use an inbuilt functionality of Cloud Build like this. So you can use a step, you use the Cloud SDK, and then you can just say gcloud app deploy. Now that's fine if you just use all the generic functions, but if you wanted to keep using our script that we've created, like this deploy script with all this versioning and all that great stuff, then we need to do it a slightly more complicated way. So we need a way to move things between our image that we've created and to deploy them using various different cloud build techniques. So I'll show you how to do this using a cloud build YAML. So let's go ahead and make cloud build.yaml. So we'll quickly outline a very basic cloud build YAML file, which will be the equivalent of just using a Docker file in cloud build. So there's two ways to do cloud build. You've got the Docker and the build YAMLs. The build YAMLs achieve a higher level of complexity. So you can see here that we use a cloud builder called Docker and pass it some variables. So we're building it, we're tagging it with our project name, and then we're using commit SHA, which is best practice for getting a unique version. And then we're using this images parameter thingy. And that's essentially just going to upload the container that we build to GCR. So that's the equivalent of that push we did before with Docker. So when this build runs, it's going to download a Docker image from the cloud builders. It's going to run it with the command build and then the tags that denote what tags we want to build with. And then it's going to upload the images to container registry. I've used multiple tags here. This is useful if you want to, let's say, have a latest and then also a versioned build. Go to Cloud Build and create a trigger. So we'll give it a name and then a description. And then for sources, we're going to set up our GitHub repository. So this is where we're going to keep our code. And then when we push to the master branch, it should run your cloudbuild.yaml that's contained within that branch. Annoyingly, it doesn't seem to preserve the name and description, so you can just go through and edit and update those. And this source is a regex match, so we want to match the master. And finally, we want to select cloud build configuration file and make it the cloudbuild.yaml. Go ahead and save, and then if you go back to your dashboard, you should see a single trigger that's showing that it's ready to go whenever you push to the master branch of that GitHub repository. We can test this by adding some files to our Git repository, and we should hopefully see a build. So we can see in Cloud Build it's running, so that's triggered automatically, and then if we click here, we can see the outputs happen live. Success, App Engine API, and then it's named based on the Git SHA, plus we have latest. So just to prove the Git SHA thing, we've got 1BB, 2B. And then if we go back here, and we go git log, 1BB, 2B. There it is. So again, very useless container sitting on container registry now. So let's explore a slightly more interesting concepts. Each time that cloud build runs, it's run within a build container, and each one of these build steps in itself is a container. So these cloud builders that you see, like Cloud Builder Docker, is a container which will run within the context of this build container. So that's really important to understand. Cloud Build uses a really simple mechanism for sharing content across your build steps, which would otherwise be isolated, by using this working directory. That working directory is mounted into each build step under a path /workspace. So using this mechanism, you can output to /workspace and then use it within the next build step. With a Docker command, you go another level deep. So we've got the build container, and then we have the build step, and now a Docker command that you're actually creating another container. So that no longer has the context of the workspace. So you need to run with the flag volume, and you pass it the workspace to mount it. So you actually can copy from your build image into that workspace volume that actually resides within the build container of Cloud Build. So we've got this beautiful little mechanism of Russian doll volume mounting. So once that volume is mounted, we can actually now run command and copy recursively from our app directory into that newly mounted workspace. And what that's going to do is it's going to copy all the good stuff that we've copied into this from our source directory, and it will output it into the workspace when we run this container. So effectively at this point, we can build a container and then we run it, and after it runs, it's going to use that command from the Docker file and copy the source files, which is essentially what we have here in our local workspace, into that workspace mount, which is in the context of the entire cloud build container. So a long and convoluted way to move our local working directory into a cloud build container. At this point, you might be wondering why we're doing all of this. It allows us to run any command from cloud build like it's on our local computer. So the next thing we're going to do is use the gcloud cloud builder container to run our deploy script by overriding the entry point. So the default entry point for the gcloud container would probably be gcloud. That's how it tends to work. And then you would have the cmd docker command, which would provide the args. Now, if we override the entry point with bash, we still get all the dependencies of gcloud, but we can run a local script. So if we have our workspace directory mounted in /workspace, then we can call the /script/deploy with all our good features like canary rollouts. And because it's within the context of the gcloud container, it's already got all the dependencies that script actually requires to run. So as that was a lot, let's recap on all of that stuff. Here we've got our basic cloud build setup. We've got the cloud build container, we've got GitHub, and then we've got our local machine. So when we push to GitHub, we trigger a cloud build, and then that in turn will clone the repository into the /workspace directory. And then we build our Docker image. So this would be good to deploy to Google Container Registry. And then we run that image, which uses a command to copy to the /workspace directory. Then finally, we run a deploy script from our /workspace directory using the gcloud cloud builder, which in this case is necessary because our deploy script requires gcloud app deploy to run. So we have a dependency on that gcloud CLI. Now you might realize that steps 1 and 2 of the build steps here are maybe not necessary, because we could actually just run that gcloud deploy script straight from the cloned repo. But it's just to show how you would go about doing that build step using Docker containers. So before we can actually run this, we first need to go to the settings of Cloud Build and enable App Engine. This is to give the service account which Cloud Build uses on these build containers access to actually deploy to App Engine. After that, you can redeploy to your master branch, and you should hopefully get a success message like this. So after that automated build, I go to check App Engine and I see it's actually not worked very well. So we put the canary flag in that deploy, and we do not see a canary deploy here. So it turns out I've actually put a bug into the deploy script. So if you just relocate the old version outside of this if statement and delete the original, and then from the very bottom, delete the old version statement from there as well. What was happening was the old version was being reevaluated after the deploy actually happened. So the current new version became the old version for the canary rollout, so it didn't actually know to roll anything out. And just like that, we have a production ready canary releasing CI/CD pipelined App Engine app.